Alright, so that is on and recording. Wish it was freaking clearer.
You couldn't hang it from the ceiling, huh?
I'm gonna have to try at some point.
So what did you ask everybody their name first?
Yeah, I was gonna ask them to let me know who is here. Please start at 11:35.
Sounds like you need to drink a water down here once in a while. Do you have one?
Brad, Sloan, Jesse.
Stop it. Get over here. Get over here.
So everybody that's in, can you hear me and can you see the screen okay? I know there is a glare at the top. I will try to get that fixed at some point. Alright, sounds good. So I'll give everybody a couple extra minutes to get signed in. I gotta get my dogs out of here. And we'll get started. Come on, girls.
Stay up there now.
So while we're waiting for other people to get signed in, anybody have any trouble? Any concerns that you wanted to go over? Feel free to let me know what you think of the setup. Thank you. Good afternoon, Dylan. I guess not quite afternoon yet, but getting there. Anyone been in contact with anybody else from class? Know if anybody's having any trouble with this? And also, how is everyone doing? Doing good. Good to hear. Alright, so I think we can go ahead and... Oh, wait. Yesterday, my crazy neighbor stopped to tell me she found a red ant and that she's related to the virus. Okay. She should probably always be quarantined. Alright, so I think let's go ahead and get started. So as I was saying in the Blackboard messages, we still have a test coming up, but I'm still working on how we're going to do that. There is a online test software that the college has purchased licensing to that allows me to basically see what you're doing while taking the exam. It'd be great if I could see your process and all your work. So I may ask you when I do get that finalized to maybe put the stuff up on the screen so I can see what you're doing on your work, and then maybe just have you choose the final answer, and then I can grade you, by your work and by your answer. I also moved the homework back. I think I had mentioned that on Blackboard to, I believe, Wednesday for that stuff. So if you guys need some more time, you can finish that up. I printed out our tentative schedule, and today was technically to be the exam, but because we're going to push that back a little bit, we're going to go ahead and look at exponential functions, and if there's time, we'll go ahead and look at algebra of the natural log function. So normally I would say, as a show of hands, how many of you are familiar with exponential functions? So feel free to put up a little virtual hand in the chat there if you like. My expectation is that you've seen them at some point, but we're going to go ahead and look at a few types here. So let me click back on the screen. There we go. Oh, my chat went away, darn it. Give me a second. Okay. Well, I did have it set up that I could move the screen with my watch, but it doesn't seem to be working right now, so we'll just use the mouse. Alright, so exponential functions. These typically have some base b. Our favorite is always e, right? The natural number, which is about 2.7 approximately. But we can have any kind of exponential function, and it'd be of this form here. It'd be some constant times b to the power rx. So b is some positive real number that is not 1, because as you may know, 1 to any number is just 1, so that is not an exponential function. And then we have c and r, which must be real constants, and we call this form an exponential function. So there's a bunch of different properties for exponential functions. The first one is that the domain is the set of all real numbers, or if you prefer, minus infinity to infinity. The range is positive real numbers, because as we'll see here in just a second, and I know there is a glare, I think, right here for you guys, so I'll try to stay away from that spot. Let me actually scoot this down just a little bit. Maybe that's better now. So this was my domain. The range is all positive values, or 0 to infinity, because we're expecting these things to look like this, and they do not go below 0. In fact, they never touch 0. So it actually says that right here, the axis is a horizontal asymptote, the x-axis. We also know that the y-intercept is the point 0c, where c is that coefficient right there. The function is continuous for all real x. That's important because that means it is differentiable, which when we get to taking the derivative here in a little while. And then these last 2 points say that if the base is greater than 1 and r is also equal to 1, the slope is always positive and y is increasing and concave up. So we don't have to do all that stuff that we learned in the last chapter. We could to prove it, but we're told that if b is greater than 1, 2, 5, 7, 1,000, whatever, and the coefficient c is 1 and r is 1, the thing has to be positive and increasing concave up, which are these first two graphs there. So these two guys right here. Then the second one says if base b is between 0 and 1, meaning some kind of fraction, so 1/2, I don't know, 7/18, whatever, right, as long as it's between 0 and 1, so 3/2 is not something that falls there, and c and r are both 1 again, well now it's going to be negative everywhere, or negative slope, decreasing and concave up, which are these two situations. So notice 2 to the power x, 3 to the power x, right? R is greater than 1. Here r is 1/2 and 1/3. That's between 0 and 1. So it's probably a little more in depth with E than you wanted to get. Any questions about those? So I'm just pausing because I know there's a little delay between what I'm saying in the stream and then your ability to respond in the chat. I'm assuming that was all review for you and you're bored out of your mind, so let's go ahead and look at these real quick. We're given two functions here, f of x equals 2 to the 3x, and g of x, which is 1/3 times 2 to the 3x. So in the first case, that constant c is 1. That went right into the glare, didn't it? Oh, there you can see it. And here, c is 1/3. So it says find f of -1, f of 0, and f of 1. So just plug them in. So I took the function f, plug in 1, that's 2 cubed, or 8. Then f of 0, just plug in 0. That's 2 to the 0. What does that give us? Well, that's just 1. And then f of 1, that's 2 to the 3 times 1. Oops, I forgot this is -1 here. Sorry about that. That's -3. And that's 1/8. All right, because we get 2 cubed into the -1, if you want to think of it that way. So we get 1/8, we get 1, and here we get 8. The next part asks us to go ahead and plug those numbers into G. Well, I did a little clever thing here. I said, well, f of x is equal to 2 to the 3x, and that's right here. So I'm just going to rename G as 1/3 f of x. And then all I have to do is, instead of plugging it in every time, I just got to take these numbers and multiply them by 1/3. So G of -1, well, that's 1/3 times f of -1, which is 1/3 times 1/8. So that is 1/24. Then G of 0, that is 1/3 times 1, or 1/3. And finally, G of +1, if you guys heard a jingle, that was my cat. G of 1, that's going to be 1/3 times 8, or 8/3. Okay, that's all fine and dandy. That was really boring, so why did we do it? Well, the next part is going to ask us to graph these things. So I see Nick says internet's having some trouble. So try and stay on, Nick. I am recording the video, and I'm trying to figure out how to best post it online for you guys when I'm done. So I've got all those numbers. All right, so I need to erase the board. So let's remember those. We've got 1/8, 1, and 8 for the first one. Amanda says, it's really hard to see what you're doing. Well, thanks a lot, Amanda. Hard wise or too much light? What are we talking about? I know the glare's at the top. It looks pretty bad. I can lower the camera. Oops. Let me see here. Maybe I might have to stop to change the resolution. It's not allowing me to do it right away. Let me try moving the camera first and see if that helps. Right. That looks even worse, doesn't it? I'm not sure why the glare is worse now than it was this morning. Bring the cat back? How about we get this figured out, then we'll worry about the cat. Yeah, that glare is terrible. So I think maybe if I stick to the right side of the board, you guys will be okay. So if I stay kind of beyond that point there. Let me also see if I can get a better marker real quick. Oof, that looks terrible. That was a brand new marker. How about that? Alright, let's go with that for now. Good, I see some betters, that's good news. I think it was the marker was kind of dying is one thing, and then the shadows and whatnot too. Yeah, really got to figure out the lighting. Okay, so before all I did was I plugged numbers into the functions. Yeah, printing the notes does help. Does anyone need me to go over what I just did? Alright, so basically I had that the f of -1 was 1/8. F of 0 was 1. F of 1 was 8. So we're asked to sketch it. So just quickly do that. -1, 1, and obviously 0 in the middle. It passes through the point 0, 1, which is right here. At -1, it's 1/8. And here it's at 8, so that would be somewhere up here. Okay, so that'd be your basic exponential. That is f of x. If I tried to plot g of x on the same plot, it would look something like that. So it does not go through the point 0, 1. Yeah, I know that it tries to refocus. That's why I try to get out of the way. All right, so that is the plot for the function. Are we okay with the plot, or is the camera situation screwing it up too much? It's good. What lesson is this again? This is, I just put this up on Blackboard a little bit ago, 5.1 exponential functions. So because I did not have the ability to give you guys the tests yet, I wanted to go ahead and start some new material. We'll go back to the test. All right, still waiting to see what the verdict is after this week. All right, so that's exponential functions. The whole point of this is to do some kind of interest formulas. So let's look at those. Darn, chat went away yet again. Okay. All right, so compound interest is another formula that I hope that many of you have seen before. And I'll write it again over here in case it's hard to see. So it is A equals P times 1 plus R over N to the N times T. So P being the principal, the amount that you invest. R is the rate, annual rate, and that has to be as a decimal. N number of times per year. Thank you guys for answering that. T is the amount of years in this case. Now you can obviously change the formula. If N is the rate that's not per year, then T can be something other than years. But I believe most of the cases will be that way. So we're given a problem here. It says, suppose that $1,000 is invested at 12% quarterly, what will be the value of the investment in 1 year? So we just need to plug all these numbers in, right? Well, first we need to determine what they are. $1,000, that's our principal. Right, so this is P. 12%, that's our rate, R. Compounded quarterly. So quarter, right, that means 4 times per year. So then it says, what will be the value of investment? So 1 year, we would just plug in, we say A equals 1,000. And then we have 1 plus the rate, which we have to write as a decimal. So 0.12 over n, which is 4. Then the power is 4, which is n, and time t, which is 1 year. Can you guys see that formula okay? Looks like it's right in the glare. Damn it. Alright, it's 1,000. 1 plus 0.12 over 4. 4 times 1. So I also have these worked out on the notes. I'm going to send that to you as well when we're done. So that way you have plenty of different ways to go about this. Alright, so just got to plug that in the calculator. I have already graciously done that. If you go and do this again by yourself and you're curious, this is 1,000 times approximately this number here. And then that gives us that for a total. Yes, Hype Man, I will be sending you the notes that I've completed. Sure, I can do that. I can send them beforehand. Anyone lost right now? Are we okay? All right, thank you for answering. So we have to do this again for 3 years, right? So we're just going to change, instead of 1, we're plugging in 3. Right, so it's the exact same equation. And if you do that calculation, we end up with that. So it looks like if we invest $1,000 with 12% for 1 year, we get about $125 back. And if we did it for 3 years, it'd be $425. I'm going to go ahead and go to the next section. Right. All right, so then the next thing we would want to do is graduate to the exponential e. And as I'm talking here, I'm going to see if I can turn the brightness down on the projector and see if that helps. Oh, it's already down. Okay. So, definition of E is given here. I personally don't care if you memorize this or know it off the top of your head. In my Calc 1 class normally, we do give that to the students. That is the definition of E. It's a limit of that function. But we all know if we plug in the calculator, it gives us 2.7 something. So we can use this now as a compound interest formula that's continuous. So if you leave something to be compounded continuously, well then we need this formula. So A equals PE to the RT. We often call it the PERT formula. So P being the principal, the amount you invest. E is obviously just the value, the natural number, 2.7 something. And then R is the rate as it was before. T is the time that you want to invest. So this problem down here gives us two situations. It says compound quarterly. And then it's going to ask us to compound it continuously. So quarterly was the previous formula. So that's A equals the principal, which is 5,000, times 1 plus, our rate is 8% as a decimal, that's 0.08. Right, we have to move the decimal place 2 places, divide by the number of times per year. So it said quarterly, so 4. And then this is n, which is 4, and the total amount of time, which is 5 years. So that would be your equation there. And if you go ahead and solve that, you should get about 7,429.74. So that's quite a bit, right? Over 5 years, you're getting about $2,400 back. Part B says to do this with the PERT formula. So if we do that, this is 5,000 times E, the rate, where are we at here? Rate is 0.08, and the amount of time is 5 years. So again, if you calculate that guy, this comes out to 7,459.12. So ironically, not a whole lot different. All right, so between the two calculations, I see that there's about $30 approximately between quarterly and continuously. So any questions about that? So I could see you being asked questions like, when or what would be better to compound quarterly, monthly, or continuously, that sort of thing. All right, so I'll go ahead and do the next part. All right, so these are kind of a little challenge question. So it says, suppose the grandparents of a child would like to make a one-time investment so that they can provide for their college education, which will be 20 years from now. Amanda, the answer to 3B was 7,459.12. But remember, I'm going to put these notes up for you, so you could always check that later. So what was A? A was 7,429. I wrote the part B above so that I didn't have to scroll. Right, the first part was quarterly, so we used the first formula that we were introduced to. The second part was continuously, so we would use the formula with E in it. All right, so how much should they deposit in an account earning 10% interest compounded continuously so that the value of the account will accumulate to $20,000? I don't know what college they're sending them to, but that's not going to get them very far, but let's go ahead and calculate it anyway. So I see you guys being somewhat active in the chat. Can you tell me what this 20,000 represents? So remember our equation, A equals P, 1 plus, what was it? R over N to the NT. Okay, I see a lot of P's. I see 1A. Any other suggestions? Invested amount. All right, so you would think that it would be the principal, but in fact, they're saying this is how much they want to accumulate. The principal is how much you put in, right? So in order to get to 20,000, we need to find P. So that's the thing we're trying to solve for. So A is actually 20,000. This is equal to P times 1 plus. My rate is 10%. So that's 0.1. The number of times per year, it actually says compounded continuously. So, I actually need to use the other formula, right? I actually need this guy. So we've got 20,000 then, has to equal P, E. Our rate is 0.1, and the time is 20 years. It's also kind of strange. I don't know who's going to wait till they're 20 to start college, unless you get held back, I guess, or didn't go in the first place. Nothing wrong with any of those options, but just a strange setup for this problem. So we've got everything here except for P. It looks a little strange because we have E here, but that is a number. So to solve this for P, I'm just going to divide by E to this power. And then we can go ahead and calculate that value. And and I get 2,706.71. So according to this equation, obviously compounded continuously is not necessarily a thing. I guess some banks may actually do it that way, but the interest rate is so low that you would never see this kind of accumulation even over 20 years. But according to the problem, if you take $2,700, you put it in the bank, in 20 years, you would then have $20,000 sitting in the bank to use for the college fund. Any questions about that guy? So I want you guys to read this problem and tell me what I should be doing. Just take a minute or two, read the problem. All right, so plug in what you know into the formula. Okay, well, somebody tell me what are we given here? So for instance, what does 50,000 represent? So set A is 50,000, okay? So A is 50 or 500,000, sorry. 500,000. And T is 20, good. So what are they asking for? They're saying how many will hear the commercial during the first 20 hours? So here the commercial says that is represented by N, so we don't have to do any fancy stuff here. We literally just have to plug in. So N equals 500,000 times 1 minus E to the minus 0.03 times 20. That calculation will result in 225,594.18 people. So I always say that you should round that up. You can't have any portion of a person. Maybe technically can, but all jokes aside, we should round that up. And that's what it gives us. So any questions about that guy? Should we round up like that on Hawks? That is a good question. I would think you should. It makes most sense to do so. The problem will most likely say round to the nearest person or round up. Right, so the wording of the problem is very important in that situation. If they don't do that and you have trouble, then you can take a snapshot of the problem, email it to me, or contact Hawks, and I will get them to fix it for you. I wouldn't want you guys losing points for something like that. Alright, so I'm going to go ahead and load up the next problem set. And we can at least get started on that guy. That's a picture of me when I went to go meet Stan Lee, by the way. Okay. So I may just introduce this to you today. I don't want to do too much, especially if you guys are having a hard time seeing. That glare is terrible, I tell you. Yeah, definitely got to get that figured out. So while I'm getting this set up, does anybody have any questions regarding anything else from the course, anything we're doing today? Any concerns they'd like to express? Let me run through the names that I got real quick to see if I missed anybody. I had Brad, Sloan, Jesse, Elena, sorry, Daniel, Jake, Travis, Brandon, David, Michael, there was Nicholas, Gianni, Amanda, Dylan, and is that Riley? Anyone I missed? So if I missed anybody, just put your name there in the chat. Will we review the previous unit before the exam? Yeah, we can do that. Kyle. Gotcha, Kyle. So who is Bonsan? Oh, sorry, Brad. Sure, if you wouldn't mind showing me how to do that, that'd be great. Amanda, these sections will not be on the exam. I just wanted to move forward. So that we didn't just lose time. So anything from chapter 5 would be on the next exam after this one that we're about to take. So I think what I might do is just introduce these concepts here, and then I'll call class a little early, and then if Brad and Amanda, if you guys wouldn't mind maybe staying on for a few minutes, see if we can fix some issues, that'd be great. If not, I understand you got other stuff you got to do. So I just want to quickly review some natural log information. So the big thing is that natural log and exponentials are inverse functions of one another. So on the screen there, not sure if you can see it very well, e to the y equals x. You can rewrite that as y equals the natural log of x. Right, so there's a way to rewrite exponentials as logarithms. And the best way to recall that is always to say in your head that an logarithm equals an exponent. So the logarithm has to equal the exponent on the e, which was y. Another thing that we can look at there is this, the idea that they are inverse functions. So as you see, we've got e to the x here. This is log of x there. And if I took this function and flipped it over the line y equals x, I would get that function. So that's one way to graph inverse functions. The other nice thing about inverse functions is that the natural log of e to the x equals x, and e to the natural log of x also equals x. So that is formally written as the function of its inverse function equals the inverse of the original function, which all equals x. So basically, I don't care what function I have, if I take the inverse of it, I get back x. That always happens. And those are demonstrated down here in rules 7 and 8. Rule 5, the natural log of 1 is equal to 0. That is always true. Natural log of e is 1. Well, again, that follows from 8. But if the natural log of e to the x equals x, well, the natural log of e to the 1 has to be 1. Rule 4, if the two logs are equal, then the arguments, the things inside the logs, must be equal. And then the first two laws, or the first three, I want to go over here on the right. Let me find my eraser here. Somehow I've lost it. Let's see if this works. All right. So the first three laws there, or rules, say that the natural log of two things multiplied together, m times n for instance, is the natural log of m plus the natural log of n. And because this is an equal sign, that can go both ways. All right, so I can start with the multiplication of two things inside and break it up as the log of one plus log of the other. Or start with two logs added together and combine them to the log of two things multiplied. So then the next one that follows would be if you were to divide two functions. So if you had the log of m over n, that's the log of m divide by, or sorry, minus log of n. So when you multiply, you add. When you divide, you subtract. And the last rule there says that if inside the log I have something to a power, this power here, this r, can be written down in front of the whole thing. And what we'll come to see, I'm hoping at some point, is that these are very powerful tools in terms of taking derivatives. So the derivative of the natural log of combination of something, that's a chain rule problem that we don't want to do. But if we rewrite it this way, still chain rule, but much easier. So the derivative of the inside of this divided by itself. All right, so we'll come to see that in a little while. And then also here, this is a chain rule. If m is some basic function, that this takes away the chain rule and makes it a product. So we'll see that in a couple sections. So I think I'm going to go ahead and let you guys go. I'm going to keep this up, I think, and I'm going to talk with some students about trying to improve it. If you have questions, feel free to send messages. You can email me. I still have my normal office hours, which I will be available. We can do Skype or something along those lines if you need. I'm going to put up these notes for you here in a few minutes, and I'll be contacting, I think it's ITS now is the department at the college, about how to best pursue the test. So I'll have that hopefully ready for you guys to take next week. So we may be reviewing it on Wednesday, potentially. So any questions before I go ahead and just end the lecture for the day? And I heard you say, bring back the cat, so there's the cat. Would tests be next week if we are online? Yes, it would be next week as an online exam. All right, so I'm going to go ahead and what would we do for the note card? The test, the homework still due Wednesday. I can potentially move it back, but I'd rather not. You certainly, if you guys want to use it as a study tool, maybe I can do that. What would we do for the note card? Yeah, let me think about that. I'm not sure exactly. All right, so I'm going to go ahead and stop the recording.